Hi everyone, TB with you here today. We're going to talk about how to repair a bad weld. This one here is porosity. Usually it starts on your starts or wind is taking the gas away. And this one here is lack of penetration or slag inclusion or a crack it could be also. Today's video we're going to show you how to repair a bad weld. Welding along here, things are going great, right? But all of a sudden the windstorm comes along, or the wind, or the pipe shifts, the ground lead for some reason falls off, and your weld stops. What do you do? You're going to use that grinder and clean it just enough so that the weld where it had stopped is cleaned up and there's no gas pockets there, and it's thin enough to burn and start adding metal to the back side so that the root bead is visible and tied into both sides of the wall. Alright, I'm going to finish this root bead, make it real nice and pretty, and on the second pass, the hot pass, we're going to say that this is where the bad spot is, and I want to make sure that it's a bad spot. Shame on me, but we're doing a video on how to repair a weld, and that's where I'm going to show you where it's at and how to repair it using the carbon arc torch and other materials and products that are available to find that weld to determine that's where it's at. Alright, I've got my course setting on 225, not on 300. Like I said, I was in a hurry last summer, and I guess my knees were hurting or something maybe, but I'm going to put it on 225. The recommendation is between 200 and 250 or something like that for that size rod that I've got. And I've got this on max 100%. Now this part of it is digital or something they call it. So this may be a little different than the older machines that have the rheostat with the wires on the back side. This has got like a disc on the inside that's enclosed. I can't even see it. Pulse or something like that. It works off of it. And but I've always done it like this. Put it on max. And I want to leave it there. I've had good luck with that falling apart. Like I said, I've done work to the bearing of the armature so that it is much beefier for doing work that I'm getting ready to do. Let's see what happens. Now, like I said, I got the negative lead is hooked up to the ground for my ground, and my positive lead will hook right into this hook into this portion here. There are different kinds of leads. My torch is a K2000. I've never needed one anything bigger than that. They're really easy to maneuver. There's all kinds of different ones out there, but mine is the arc air torch, and I've always liked those. Also, before I get going here with it, there's 3 holes here. the air comes out of it. And you want these 3 holes under the weld. So if I'm gonna hit that arc this way, I want the air to go under it. And I don't go very far with the rod. You get out there too far and it seems to just kind of not want to push. It just floats around. So I only go about 6 inches away. You got to watch turning this. You got to get the angle that you want and then get the rod in there. Because if you go trying to spin it, you'll break this off. They're that sensitive. My air pressure is probably 125 to 95 psi. That's when the air compressor comes back on. If you need to put a pressure regulator on it to make it what you like, thumbs up, do that. But how many times is everybody going to have that regulator provided if it's a big air compressor or if it's plant air, or if a contractor just wants you to hurry up and get it done because they don't want to spend any more money? You got the tool just to get it done. See what happens here. Like I said, you got that air coming out and it's going to go into that. I'm on 225 amps. Now I've got a spot where the soapstone is where I had lack of penetration. I know it is. So that's where I'm going to concentrate. On the x-rays, it should show up an area of a real dark black area instead of a light area where there's slag inclusion. So that slag inclusion and that's lack of penetration on the wall. All right, I know my starts are not real good here. But eventually I get comfortable and it starts to just cut continuously without choppy. Start stopping on the gouging. Also, I want to add, leave the welding machine on high idle. The RPMs are at maximum speed. That way there's less load put on that machine when you strike that arc. Alright, while you're gouging this out, you're paying attention to the bottom of the area that's been cut. We don't want to cut the whole weld out. We just want to cut it out and find that dark line like a pencil lead area that the weld didn't penetrate the wall somewhere or the next pass under it. So you're going to take cuts at it slowly and getting that dross out of the way, letting the air push it forward out of your way so that you can see the bottom of the cut where this area that we're looking for that is a bad weld. Sometimes you need to just stop, lift the hood up, and also look around where you made that cut and make sure that you haven't went too far and observe what's going on. Alright, it's getting dark out for me. The camera looks pretty good. So you can see there's a spot right there. It's too hard for the light. If I get soaked. Alright, it's the next day. It got dark on us last night, and I was trying to show you the crack or the insufficient penetration right here. There was slag inclusion. I want to wire wheel this out, and then I want to show you another way to look for it. It helps determine it even better. You can see it. It's right there. What I'm showing you now is there's 3 cans of this test that is used, and it's a liquid dye penetrant test, and there's a cleaner, there is a penetrant, and there is a developer. And you want to clean the metal first, get any grease, any things that are contaminating that will cause the penetrant to not find the areas that there could be a possible crack or porosity. So what we're going to do, we're going to use the cleaner first. This is Goodson. I forgot to tell you, you can get this at, it's been so long, I think I got it at Summit Racing. And straight, you can get stuff straight from, well, I could have got it straight from Goodson. It's been a few years. I used this when I was welding on my aluminum. Should spray better than that, but anyway, you spray that on there and you clean that area that we just dug it out. And then you spray the penetrant on there. Not very much. Just, you can do it with the brush. You don't want to use a rag. You spray it on there lightly, like I just barely hit that. Spray it on there lightly, and the can tells you how long it should be that it needs to be there. Instructions. 1 to 5, allow it to stand 1 to 5 minutes. And some companies I've been at, there's a minimum of 7 to 10 for the penetrant. But this company says 1 to 5 minutes. But you do what your company wants you to do. So we'll leave it there and we'll come back here in 5 minutes. Alright, let it set for probably about 7 to 10 minutes. And you notice it's dried. There's no puddle there anymore. It's dried into its spot. So now I'm going to spray the cleaner onto a rag. And I had a rag. There it is. So it's windy out. And it's not spraying. Golly. Yeah, we'll just let it run out of the can. Anyways, you let it run onto a rag. And then rub it back and forth. See how it's coming up, the excess is. So it's windy out. Keep rubbing it till the outer part of it is cleaned up. So we're going to need more cleaner. like that, and until the majority of the part of it that is gone. Then you put this stuff on here. It's called developer. That stuff ain't spraying real good either. There, it's sprayed. And this stuff you're supposed to take like 10 minutes to let it dry. All right, I couldn't get it real clean, but this is it right here. There's a spot right there that is really bad. The rest of it down in here, there's some spots down in here that's still where it picked it up. There's a little pinhole right there. There's another pinhole there and there, another one right there. There's definitely a crack right there. That's lack of penetration. So what we're gonna do is we're gonna clean this back up. Now I'm just gonna use a grinder and go over it lightly. And then we're gonna re-weld over that and fill it back up. And then when you're done welding it, you'll buff it and clean it with a wire wheel. And then you tell your x-ray crew, or you fill out your paperwork on it that has been repaired, and then if x-rays are required, then they'll come back and reshoot it. That's what you do. Cleaned it until there's a little bitty spot right there. It's less than a 32nd of an inch. I will be able to burn that out. There's a couple more in there. It's clean down to the root. So now I'm gonna set this up and we'll start welding it. All right, the weld's all cleaned up. It's feathered, tapered. I gouged out on each end. I want to start about right here because it's the lowest part. Put a bead in here all the way to there, and then clean my start. I burned into the walls and putting it on with a smaller rod so that the flux doesn't overcome the rod as it's burning in. That's digging pretty deep. Probably getting cherry red on the back. Now this is the hot pass. You're redoing it, or I'm doing it, and you want a puddle big enough to burn down into that root bead and into the bevel of the material. So you can run steps or a circle, or I'm going side to side, just barely side to side. I'll go to a bigger rod. It's 532, the first one with an 1/8 inch. I know this is downhill. That's a good start. I don't need to clean that. I start down here and I work my way up. Okay, I don't like that. I want a little more amp, about 10 more. See that right there? Like fish eye. Gas pocket. It'll blow down. On the welding machine, the core setting or the gear selector, I've got it set on 180 amps, and on the rheostat, the fine-tune setting, it's down there where between 140 and 170, and whatever makes a good puddle. It's pretty hot. It's probably every bit of 160 to 170 amps. The wall thickness on this material is 0.375, and this is the second filler pass, and your amperage is going to be the same, the 130 to 170, and your voltage can be anywhere from 18 to 34, but 22 to 28 is ideal for your pass. The voltage on that current. This side-to-side motion is not always what you're going to do. When you have a tighter bevel in the cap, you can circle it. But you got to watch both sides of the bevel, making sure that you do penetrate and cover it, and you make a uniform weld. And when the weld's a little bit wider, you're going to step it side to side going downhill. This is just a real quick pass of 7018 uphill. You notice the direction of travel side to side. It's almost identical to downhill for the cap, just a little bit different. You can do an upside down V, it's called invert V, or a U shape, but you got to watch the edges so that you do not have drip from excessive weld, and that you have the right amount of time in the middle so that it is uniform. You don't want any undercut either on the edges at the toe line. Well, everyone, the weld has been buffed out, and this is exactly how you would repair a bad weld. If you like this video, please give me the thumbs up, and if you've not subscribed, please do, and hit that notification bell for future videos. Thank you.